Alright, now we're in the last section of the Point Cloud Assistant, the Tools section with the orthographic image feature that we will explore in this video. We will also cover the image vectorization tool, even if it's not new, since it was already in the Smart tab under vectorization. We're going to take a look at how this tool fits into the Point Cloud Assistant workflow. And at the end, we will look at deviation plane analysis, also called flatness analysis. Alright, so let's start with the orthographic image tool. But first, I would like to make a few adjustments to my slice thickness to remove the flaws. Perfect, so now only the walls are visible in my slice. Alright, so let's switch to top view, and now we are ready to launch the orthographic image. So by clicking on it, this window appears, and here I'll leave the settings as they are, and I'll briefly explain them. I'll keep the current view for the projection since I've already set the top view, so there's no need to adjust anything here. For the image range, I'll choose the entire slice by drawing a simple rectangle like this. Here's the ortho image resolution. So the image width and image height in pixels, and here's where I set the export location. So let's select our path and create a new folder for this export called Export Ortho. And then we'll name this export Image1. Alright, so let's save this path, then I hit OK. It created the orthographic image. Now I'll go here to move it a little bit. And you can see I now have my plan traced in an orthographic image. Now that we have that, what can we try to do? We can go back to the Point Cloud Assistant. And we're going to try using our orthographic image here as a source for the vectorization tool. But here it says the orthographic image resolution is too high because it exceeds 2048 by 2048 pixels. Why is it saying that? That's because there's a vectorization tool, a plugin that lets you go beyond this limit. So if you exceed it, you need to buy the plugin. In our case here, we're just going to cancel and we'll make another orthographic image. This time here, we'll limit our resolution so it doesn't go beyond 2048 pixels. And then proportionally, the other values update automatically. So let's export it again, and this time I'll name it Image2. So let's save it and hit OK. Now I've got my orthographic image at a lower resolution. Let's just move it slightly to the right. Alright, let's place it right here. And now the vectorization tool should be able to work with this ortho image. Alright, apparently it's already done, so if I delete the image, I should be able to see the result. So of course, the result isn't perfect with a lower resolution, but you can try to improve the output by going to the Smart tab, then the vectorization configure, where you can tweak different parameters to get better results. So here, the vectorization configuration settings are always accessible in the Smart tab, and you'll need to experiment a bit with the parameters depending on the point cloud to find the sweet spot. Alright, so that wraps up the demonstration of this workflow combining orthographic images and vectorization. Now, to talk about the last tool, let's hit Ctrl-Z a few times to go back to our initial point cloud slice. And if you remember, in a previous video, we drew a plane in this point cloud slice. So, we'll bring it back into view there. We had used the Fit Plane tool to create this rectangular plane. And we'll use it now for the last tool called Deviation Plane Analysis. When I click on it, this window appears and it prompts me to select a plane. So I'll select the plane we created earlier. And now I'll run the analysis deviation over analysis range of 10 centimeters. So here is the result on the deviation distribution histogram, and given this result, we can try to refine it further by reducing the range to 1 centimeter. And here it looks better. Now I can increase the number of colors for the deviation display, so let's set it to 10. And here I can choose where to export the result. So let's create a new folder called Export Deviation. And inside this folder, let's name our file Deviation Analysis. Let's save it. And now we're finally ready to hit OK. The plane deviation tool is now calculating the distance from each point to the plane, and here you can see the result with colors representing that distance. So in summary, it's a very useful tool for checking the flatness of a surface captured in point clouds, or for monitoring structural deformation that is invisible to the naked eye. And that's it. Thank you very much for staying with me until the end, and I wish you lots of success with your future projects using ZW Soft products.